And then now I'd like to pass it over to Jassimran to do her presentation on getting insights from noisy user-generated content.
Thanks, Natasha. Let me quickly bring up the slide deck. Awesome. Hope you guys can see my screen.
Yep.
Great. So yeah, today's topic is the main theme is impossible data science. I think this is really something that excited me, and because we started working with user-generated content. So a little bit before we jump in, I am right now the tech lead for AI research at BBTV, and we are a media tech company who are helping advance the world through creation, management, distribution, and monetization of content. So I have been at BBTV for about 2.5, 3 years now. Before that, I was at IBM Research. So I come from a research background, so not an applied ML person. So my journey was definitely an impossible one when I started working with the real content out there. So let's just jump right in. So what is user-generated content? We see that this is the content which is posted by users on online platforms. It could be anything like videos, mostly social media content. So be it tweets, your Insta post, TikTok, Reels, anything. So it also includes some testimonials, product reviews, live streams, discussion posts, Reddit, and then blog posts, pictures, like you name it. I think, that's why internet has grown so big, because there is user-generated content everywhere now. So we want to know, why is it important to really understand this content? You would see that it's ubiquitous, right? It's everywhere. Nearly 6 out of 10 people now prefer online video platforms to live TV, as they can relate to them more. Some surveys show that 60% of the products are discovered via Instagram. 41% of the internet users generate content. So you can imagine the volume, right? 95 million photos and videos are posted on Instagram alone per day. So we want to understand it for sure. Because of this large volume of data, now this user-generated content, it acts as a modern day word of mouth. In traditional times, we would take advice from friends, right? It acts as a trust signal. Like, if I go on maybe shopping on Amazon, I always check for the reviews. I always check for the star ratings. Those are my trust signals. Only then I go ahead and buy something. And then this is really more cost effective as compared to influencer marketing, because you trust the people you know as compared to influencers, right? And then more than that, because this user-generated content is everywhere, a lot of new issues are coming up, like there is misinformation, there is hate speech. People are more radicalized than ever. Let's just take some examples. US elections recently. We don't want people to be radicalized, right? So let's see, what can we do? We need, I would say, world peace. So we want to understand user-generated content. And then let's see what really makes it challenging to work with. We have been working on all these techniques to understand data from years now, but what's so special about this user-generated content? Here's a screenshot from one of the comments of YouTube videos. So let me just say, if somebody asks you to find named entities, right? Named entity recognition is a known NLP task. Good luck finding that, because you see, people are talking, crazy stuff. So Justin, Gaber, Swiffler, we know who they are, but finding them in this UGC is difficult. So what are the challenges here? It's noisy, it has slangs, grammar doesn't apply. At times I wonder, like, have they stopped teaching grammar in schools, or is it just that people are looking for shortcuts? So one of the solutions is actually start teaching grammar in school, but I don't think that's going to solve the problem. So then we have hate speech, right? There is non-canonical text. Here is one more example. These are again some comments from YouTube video. So firstly, if we look at the video itself, right, we put a lot of emphasis on titles and its description. Like, if you ask me for analysis of this video and how good or how searchable this video is, like, I won't be able to do much about it. And the kind of comments, at times I feel like, do I even belong in this generation, or I just don't understand things that well? But the problem here is a lot of this data is just like nonsensical. It's just hard to make sense out of it. Extremely noisy. Okay, if I ask you to do a sentiment analysis on rock, dog, like what? Yeah, impossible for me at least. And then there is colloquial language, there are emojis, stuff like that, which makes it really hard to understand. Terms like bangolang, right? Brother evolved from brother to bro to brother to, just we need some lexical normalization of this text to really make sense out of it. And then other than that, we see that content these days is multilingual. The world is becoming a smaller place. We want to try Lebanese food, we want to try Korean food. So we go look for those videos, but some of the content is in different languages. Other than that, so if you look at more text out there on other platforms, you will see, oh, this definitely looks like English, but I can't understand even a single word out of it. Yeah, this is all English, but maybe I make sense of the word lover. Other than that, yum. So what's the issue here? It's all code mixed. Person is trying to say something in maybe Hindi here, but it's all code mixed. More challenges here. Now you have multilingual and code mixed text. So for example, masala, right? That's like used for Indian curries, but we use that word as if it's native to English language. It's really not. But then there are like more languages, then there are English texts, which is not really English. So now this makes it even more complex, multilingual and code mixed. Okay, so this one is my favorite. So if we see that here is a review of an Amazon product, this person says that he got his mother-in-law for the bath time and hoping it would be crap. Her Kindle would slip out of it and electrocute her. And he says that so far, this bloody thing is staying in one piece. So great for waterproof kindling, but crap for murder. So what would I call this? If I have to do star rating on this, is this person being sarcastic? There is humor, irony, all of those are like issues here. So what he's really trying to say is that this is a great product, but from this review, can we really make that out? Probably not. There are keywords like murder and electrocute and bloody thing. So yeah. So these are just some examples. Now, if I have to, give or maybe convert them into machine learning problems, how would I approach this? I've taken some examples on different social media platforms on why we need to understand, and what can we really do after we understand this user-generated content. So for maybe YouTube comments, right, we would want to know what's the overall sentiment of the content. Are people happy? Are they liking it? We want to know, we want to do emotion detection. We want to understand what the fans are talking about. So simple things that we can do is named entity recognition. And we want to know, are there any celebrities talking in there? Maybe more product reviews. Are they talking about certain things, some interesting events, some interesting places, food, stuff like that. On the product reviews, for example, on a platform like Amazon or Instagram, we can do like aspect level sentiment analysis. So we could say, okay, for this party, overall, it was a great party, but the food, not so good. The decorations, amazing. So just on certain aspects, if we want to do analysis, that's possible. We should be doing that for user-generated content. We want to be aware of if there are any fake borrowed reviews. Something that's becoming really popular now is the multimodal sentiment analysis. So not just relying on text or the star ratings, but we have pictures, we have people posting GIFs around how they feel about this content. So maybe using them also to come to some insights. So for Instagram, it could be like hashtag recommendation, hashtag rankings, finding fake followers, finding some competition for you, like who are the people I'm competing against. On platforms, maybe like a Wikipedia, you want to find misinformation because there is misinformation on Wikipedia and we really trust that. So we want to make sure that people can have that trust that has been established over so many years. For maybe YouTube recommendation, this is a social media platform and we want to suggest better title, description, keywords. We want to detect inappropriate content there. We want to find maybe competitive channels, find collaborators, engage with your fans, finding your best fan, and then maybe selling them NFTs and stuff like that. So we want to understand this user-generated content, and these are some of the ways through which we can do that. So let's come to our project. So we at BBT, we mostly work on YouTube and Instagram, TikTok. So one of the needs from the team was, hey, Sony has come to us and they have been posting their movie trailers for some time, but we want to know how are the fans engaging with it? Can we know more about that? Maybe if we process the comments. So we do understand, oh, there are a number of likes and number of dislikes, and YouTube provides all these metrics like watch time ratios, but there is so much more information in the comments that we can use. So we started our So Much Possible projects. And then the first step here was who needs it? It was the channel growth team because they want to grow the channel. And then we thought they want to also understand why certain watch time pattern exists and maybe get some explanations for this. So maybe after like 40 seconds, you see your watch time drop drastically. Can we have an explanation for this? Probably there is a possibility we might be able to find something in the comments. So then we thought, okay, we're going to do this for the channel growth team. Let's see who could be other stakeholders, who else can benefit from this. Probably creators, because they want to know who their fans are, what are they talking about, and improve the engagement. It could be our ad sales team, because ad sales always looking for content on which there is a lot of fan engagement, possibly positive fan engagement, so that they can bring in a lot of views for the people who want to advertise. And then it's also important for our trust and safety team to have quality content. Comments could provide a way for you to detect if there is something inappropriate. And it has been studied quite a bit in the past. So now from these requirements, we want to go to what is really needed. On a high level, we would just say, can you give me the overall sentiment of the video and what are the fans talking about? So just a small summary. Now, if we want to translate them into machine learning problems, the top of my head, I would say, yeah, sentiment analysis on comments, emotion detection is possible, named entity recognition, keyword, key phrase extraction, maybe topic modeling, and then maybe text summarization, because what channel growth team asked for is a bi-weekly report of channel level comment insights. So for this, okay, we have the requirements. So under the hood of this, what are the possible ML problems or ML challenges that we have to resolve? So we know that we need to be robust to the noise, language identification, right? Then there has to be text summarization, rumor detection, emotion detection, lexical normalization of the text. This, if we give this to models as is, yeah, God knows what will happen. And then we want to do some sentiment analysis, detect sarcasm, detect insult, hate speech, colloquial language. So all these like come to the top of my head. Yeah, these are the problems I need to solve to make this text consumable and give channel growth team the output that they need. And then where do we start? So this is like my first year at BBTV, and I'm like, yo, sentiment analysis. People like, it's so easy. Why have you not done that so far? Because like, who can't do sentiment analysis, right? Now you guys would be thinking like, who is this person? Thinking about that sentiment analysis is still a cool problem to talk about. Like what, are you from Jurassic era? Have you not solved this problem as the first project of your school? I did it. I did it like, so, but I'm gonna tell you why even sentiment analysis became an impossible project. But at that time we were very confident. This is easy peasy, right? So we came up with the master plan. Okay, business wants granularity. So they saw that our competitors have a 5-class classification on, oh, extremely positive, somewhat positive, neutral, very positive, or somewhat positive. So they asked, so we want something like that. And then our job was, okay, there is no labeled YouTube comment data set with a 5-class classification, but you know what? There is SST5 data set, tried and tested. Why not use that? And then we came up with a plan. So the choices of models that we would go ahead and train. It's always good to start with like simple and go to more complex. Now, this was the fun part. So that's why you can see there is a long list of models that we wanted to try. So we obviously start with simple, naive, wise, and then we go to a library called VADAIR, which is a library developed at Georgia Tech. And it's mostly lexicon and rule-based sentiment analysis tool, specially designed for social media platforms. So it was definitely worth considering. Then we thought fast text. It's really fast. It is a character level, embeddings, and then it has been trained on, I think the embeddings have been trained on more than 105 languages, and it handles out of vocab words easily. And then there is Flair, which was also a character level LSTM model, right? And then next one was Elmo. Elmo kind of looks at the entire context of the sentence, not just the keywords. So till I think Flare, the embeddings were mostly word-based, but now Elmo was the one that started the era of, like, hey, let's take the entire sentence into consideration before we, put it into some embedding space. So it was good to try that out because it started the era of language modeling. And then obviously like transformers, that brings smile to everybody's faces. So we wanted to try out BERT, we want to try out Roberta, Electra, and then XLM Roberta, right? This solves the problem of handling multiple languages, multilinguistic text. I think XLM Roberta large has been trained on more than 100 languages. And then we also wanted to go for something which would work well with, let's say, noisy data like BERT tweet. So the plan was, okay, let's validate the results on in-house YouTube comments data set, because this distribution is what we really wanted to work on. So we started our journey. And I am sure that a lot of you guys can see a lot of failures here already, but yeah, we started our learning journey to success. So this is just for fun. The expectation of the team was, oh yeah, we're gonna do a lot of machine learning, deep learning. Yeah, let's get this party started. But what was happening was the data gathering process, understanding the problem, data cleaning, engineering, feature engineering. And at the end of the day, machine learning was just like 10% of the job. And then maintenance was going to be a huge part of this as well. So let's start with what did not work, what failed, and why it made this simple problem of sentiment analysis not so successful. So first one, assuming that sentiment analysis is a solved problem. Like, we were so confident, we were like, hey, the classifier will be ready by end of the day. Okay, I did this as my college project, so it's very much possible. And then you sort of look at the numbers, right? You say, yeah, sentiment analysis performance or state of the art right now is about 96 to 97% accuracy. So yeah, we can achieve that. But the problem is that performance of sentiment analysis on the research data sets is actually very different than your real user generated content. So problem number two, business, what business needs and versus what's feasible. A business wants 5-class classification because our competition is doing that. So try to understand what are their 5 classes. What's really the motivation? So what happened is we told them, hey, state of the art for 5-class classification is 59%. Why not use binary classification, because that's 97% accuracy. So the problem is like, okay, without looking at what really YouTube comments entail, what's their data like, we are jumping to conclusions because, oh, business wants 5-class classification. Then we figured out, let's look at the possible solutions. So funny story, when I joined IBM Research, my mentor was working on data quality project, and I asked him like, what's his job role? He told me that he's a data looker, which is like, okay, you're just gonna look at the data and not do anything about it. He's like, yeah, your brain has this power to make some patterns and connections that only you can understand if you really look at the data. And personally, as a machine learning engineer, coming fresh out of college, I was like, no, what do you mean by look? Let's just do something about it. So I would highly recommend to be a data looker, because what you would find just by looking at your data is it's going to save you a lot of time. So when we started really looking at the data, we saw that YouTube comments, were they just negative or positive? Could there be 3 classes, negative, positive, neutral. How about 4 classes? There were some comments which were mixed. And then should we just go the traditional way, 5-class classification? But then somebody proposed, hey, how about 6? Because there are still some comments which are mixed and we don't know what's the right answer for them. So these are the possible solutions that we propose. Look for what would really make sense and do a cost benefit analysis on that. Now see, if we go for a 5-class classification, you know what, it can be merged to 3 classes because we can say that very positive and somewhat positive could just be positive. Very negative and somewhat negative could just be negative. So think about these things to find a good solution. So next one is underestimating the need of right data set. Yeah, we didn't had any data on YouTube comments, a labeled one. So there was a lack of domain specific data. We understand that, you know, generalization is possible now, domain adaptation is possible, but then yeah, having that domain data definitely, you know, gives you a long way ahead. So, and then there are some choices of data set that we had to work with. We were thinking, oh, do we need a noisier data set than SST2? We also wanted to be cognizant of if we are meeting the 5 V's of big data, you have that value, volume, variety, velocity, veracity, right? The possible solutions were, okay, fine, a YouTube comment label dataset doesn't exist, but there are possible solutions, right? So domain adaptation, what we need is from movie sentiments to YouTube comments. So there are some model-centric approaches here. For example, people have come up with feature-centric approaches where they use denoising autoencoders and then stack denoising autoencoders, which can somehow deal with speed and scalability of the high-dimensional data. And then there are some loss-centric methods which are equivalent to, I would say, GANs. What GANs try to do is minimize the discrepancy between your training and your synthetic data distributions. However, the domain adversaries were derived from GANs, and they try to learn a latent feature representation in a way that you reduce your discrepancy between your source and your target distributions now. But as we know that GANs suffer from vanishing gradient descent problems, and they're really hard to converge. So there are other data-centric approaches that we tried. One is pseudo-labeling, right? You use a model and then you apply a certain classifier to it and you consider those as like your golden pseudo labels. Another approach is, which is actually getting even more popular these days, is your data selection. So you use some sort of similarity measure, maybe perplexity, KL divergence, Jensen-Shannon divergence, or to select the data from your domain to the target domain. And then obviously with the advent of transformers and the whole era of transformers, they have really revolutionized the way we go about domain adaptation. So what you can do here is you can have multi-phase pre-training. So you do language modeling on certain text and then fine-tune your data on more specific task-related texts. So next failure is, okay, now that I have the data, I have tried to do everything possible, but there is still very low accuracy on my test set. I'm going to add more data, but no significant performance improvement has happened. We all run into that problem soon after we try out few exciting things. So like I said, look for, be a data looker, see what's causing that low accuracy. The goal should firstly be improve the existing data that you have. Other things like do good hyperparameter search, check for underfitting, overfitting, stuff like that. But if you still have the resources, it's okay to go ahead and add more data, because adding more data doesn't always improve accuracy, because at the end of the day, you kind of have to live with the natural noise of the data as well. But a lot of times it does help. So if you have the resources, go forward. When you start labeling the data, keep in mind that how the original data that you're using, how was that collected and labeled. Probably use a high interannotator agreement score, because it's really subjective. What's positive for one person might not be positive for another. So now next failure. So we are expecting some sense from this completely nonsensical data here. And we know that, okay, noisy data is like Achilles heel of BERT. It's a known issue. If you ask me what was the sentiment of rock dog, I can't tell. So humans can't even tell. And it has been found that humans don't have 100% accuracy on sentiment classification. We only agree about 84% of the time. So then there is the challenges that we have talked about, code switched, misspelling, multilingual. So some of the possible solutions to work with. There are traditional techniques like tokenization, removing punctuation, lemmatization, handling typos, maybe using extra libraries to replace the typos, and then handling the emojis, making sure that all kind of noise is removed, stop word removal. People have used text augmentation extensively, and I have personally tried it as well. And then there is the new way of doing things now, because UGC is everywhere. So you do lexical normalization using some deep learning methodologies. And then I think the choice of your tokenizer that you use, that really makes a lot of difference. So if we were to go with, for example, fast text, right? The tokenizer would be character level. That's why we went with the fast text as a good choice, because it's not word level. We are expecting a lot of out of vocabulary words here. But with the new developments now, we have better encoders. So Roberta, it used a byte level byte pair encoder. BERT used a byte pair encoder at like a character level. And then now there are word piece and sentence piece encoders. So your choice of tokenizer is going to make a lot of difference in understanding how many out of vocab words do you really have. And then another solution here is use a pre-trained model, which is trained on which the language modeling problem has been done, maybe using a really noisy user-generated text. So I think that's one of the differences between BERT and Roberta also. So on Roberta, they added this CC news, which was much noisier as compared to the better quality data that was used for BERT. And then, yeah, use multilingual text, pre-train your models on these. And this is happening. Another thing that we found, which was specific to this problem, is like, okay, rock dog by itself doesn't make any sense. But if we try to go from the beginning and read all the comments in a sequence, adding the previous comments context would give some sense to us. And then, okay, next one. Not understanding that machine learning models are a part of a bigger system. We are like so hooked onto this, making this system work. We don't understand that there are ways outside of this model also through which we can actually improve the overall efficiency of the system. So, and there are decisions that have to be taken. So for example, how many comments do you really want to process? There are videos with millions of comments. Yeah, it won't make sense to process all of them. And then should we use like top comments or should we use the newest comments? They do make a lot of difference. Then what about the cases where there are just like 15 comments? Does it even make sense to do sentiment analysis and give those numbers out there? Then there are like, how do we combine them at a channel level? So think about these as a problems as well. Some of the things that we tried and worked for us was, don't try to process all the comments. Just find the best distribution in the data set that is representative of your comments. So if it's a weekly or bi-weekly reports, only process the newest comments, maybe check with the client if that's something that they're okay with. Now, presenting this output was a big part. Do you want to make sure that they're able to drill down? It's not just, hey, the comment overall sentiment is positive, voila. No, you want to know more details. And then maybe use some tools for explainability of this. People like that, and that's a problem with machine learning models. They're not explainable. So use things like Line or Sharp libraries to give some explanations. Another one, chasing the perfect solution for too long. Yeah, you're like, oh, 97% accuracy, never 97%. I can do it. I'm going to do it. And you just waste months and months trying to do that. Rather than that, try to like get a bigger picture. Is that really that last 1% increase worth all the wastage of time? It's much better to use put a crappy model out there and get feedback from people and improve it, rather than chasing that last 1% accuracy. I think the time that you put to take a big model, benchmark it, and then use a low resource intensive model and put that into production with the compromise of 1 or 2% accuracy is time well spent. So consider using model compression techniques like distillation, quantization, pruning, and stuff like that. Failure number 8, not being considerate of the environmental impact. Yeah, we have to understand this. It's our responsibility to make sure that we are not reinventing the wheels. So please do your prior artwork. If you think something is a problem and it needs to be solved, I am sure like somebody has thought about that. So read. And as an applied researcher, trust me, you will never have to train a model from scratch. Especially these like big language models, right? There are so many models out there. Maybe go to Hugging Face or different models out there to understand that you don't have to train anything from scratch. Just fine tune it for your tasks. And then be cognizant of your carbon footprint. So there's this famous example that Google did their auto augment work where it costed them about 15,000 NVIDIA Tesla P100 machines just to find, or maybe we can say about $37,000 to find a good data augmentation policy for ImageNet. Yeah, that money is not worthwhile of spending. So another one, not being proactive about the ethical implications of the model. This is something that people don't really care about, but you should be worried about this. It's our responsibility. We need to develop responsible AI. So 2 years ago, there were not a lot of things out there, but people are more aware of this. So use toolkits. I've listed a few things here, and I personally, I have contributed back to AIF 360 when I was at IBM Research. So it's a great tool, very easy to use. Definitely consider using them. You want to be transparent. You want to be legally compliant. You want to be able to explain the decisions. You want to be ethically on the good side. So some other failures, I know I've not covered everything. There are 1,000 other things that went wrong. But some more things like think your ML model as some magic box. A lot of interns, they do that. Just give it anything. It will give out amazing numbers. Don't do that. Trying to force your ML models in places where simple solutions can work. Yeah, simplicity is always better, always. So a very simple example is we were supposed to do emotion detection on YouTube comments. Guess what we did? Very simple solution. We took all the emojis that were there in the comments and gave did a distribution of them and said, hey, this is the most popular emojis, because on YouTube comments especially, people use emojis a lot. And then we had another emotion detection model. Guess which one performed better? Just doing or showing a distribution of our emojis. So go for simple solutions if you can. Rule-based systems are more deterministic. They're good, they're lightweight, not resource intensive. Another thing is forgetting to put the required emphasis on your engineering and production systems. Please use ML pipelines. The tools are out there. Don't try to build something in-house. You're wasting your companies or your resources out there. And finally, understand that once you deploy this model, this is not the end of it. This is just the beginning. Monitoring your model is crucial. You want to be looking out for the concept drift, right? You want to be making sure your inference time, the way you are processing it is well within the limits of the resources that you can afford. Yeah, and so these are some of the references. And yeah, thank you so much. I'm now open for any questions.
Okay, yeah, I'm gonna just open up the Q&A because during your presentation, people have been submitting questions on Mentimeter. And then just a reminder for everyone, I'm still reading the questions as they come in, so it's not too late to ask any questions. And also, please upvote any questions you want to make sure we'll answer. So with that, I'll start with the first question. How do you communicate to the business team? How would you communicate to the business team why you need to change the solution? For example, you talked about the business team wanted the 5-class classifier, and then maybe you switching to binary classifier. Yeah.
So business people are always going to push you, right? But you being as a data scientist or the one who knows the facts, the numbers, you present them with those numbers. So in our case, what happened was we gave them a solution which was not so good and they didn't use it. And then they're like, no, the solution that you build is not good enough. I'm not going to use it. So we learned from that. And now we know, all right, you want something usable. So I would say fight with your numbers, fight with the facts, fight with science, right? You're not building this up. Show them some experiments and show them this is what it is. Your competition is doing this, but let's dig down. And actually, we did that. For TubeBuddy and vidIQ, they are competitors. We went down and see what they are doing, what are their numbers. So we now, whenever we do build a new benchmark, we try to benchmark it against our competitors as well. So yeah, fight for it.
Cool. I love that. The next question is, how much time did you and your team spend choosing the tools, adjusting different configurations, and tuning the models? Is there a way to measure the progress outside of the final accuracy scores?
Okay, so like I said, we planned to build the model in one day, but obviously that didn't happen. So it took us about 1 month to get the model that we wanted. But that journey was about 1 week of prior art. definitely spend, I think that's the time well spent. You will save yourself a lot of compute resources, a lot of surprises. So read. A good breakdown is, obviously, I definitely try to take 2 weeks out of any project to do a good prior art. We as a team get together, read the papers, discuss the ideas, and then we finalize, hey, let's pick up these things because they make more sense. And then, yeah, don't look for just accuracy as one of the numbers. There are numbers beyond accuracy. So for example, a very simple thing for sentiment analysis that I always see that people don't account for is, my comment has been labeled as very negative. However, it should have been very positive. Now that's a bad classifier. But if your comment is very negative and it has been classified as somewhat negative, you know what, it's fine. That's okay. So use that as a metric rather than maybe a root mean square error or mean square error, or maybe Westerstein distance, stuff like that. Those are good measures too for sentiment analysis, at least for like applied ML. Does that answer?
I think so. Yeah. And going to the next question. How do you get the data for, or like, this is a very specific question, would you get the data for the YouTube comments in the Sony example? Does the client give it to you? Did they buy it from YouTube, or does someone have to scrape it at your company?
So actually, BBTV is, we manage a lot of content for our clients. So we are partners with a lot of these companies, and we manage their content as well. So if you would see, I think back in 2020, every one in 3 videos that you would see was actually BBTV content. So we basically have the rights for all of that data, and yeah, we manage their content, and that's how we got it. So same for our Instagram collaborators, we have access to their data and they understand that this is what we're going to do with them. Yeah, so we use that as our test data, but for training, we relied on SST2 data set, like I said, and then we used or curated some data in-house as well, which was something that we felt our model was failing on. And it was the major part of the project. So for almost entire 1 month, the data collection kept on going on, and it's still going on. We do like quarterly checks, and we add more good quality data and see where our model is failing, and we try to add that back to the training data.
Is it also too, maybe because like as like slang changes, especially like now it just keeps changing, like with TikTok and stuff, it changes faster and faster. Is that part of it?
Absolutely.
Yeah.
So the concept drift, right? That's an ongoing issue. So for the models which were trained before COVID, right, we would never see that term, but now it's used everywhere. So you want to manage that concept drift in your data.
Right. So cool. The next question is, I think you kind of talked about it, but in general, are emojis or text with emojis easier to analyze?
Yeah, I think it depends upon the problem. So for sentiment analysis, right, emojis convey so much information. I would never want to take that out. But let's say for named entity recognition, emojis they're just noise in my data. They don't really serve a purpose. In fact, they add noise. So I would kind of like get rid of them. So like I said, it depends upon the task. And for example, like I said, for emotion detection, that's what we ended up doing, just using the emojis. Like it's still unbelievable that it works better than the machine learning model.
Yeah, just a smiley face or whatever people use. And the next question is, do different social media platforms have different sorts of comments, different types of comments?
Oh, absolutely.
Yeah.
Absolutely. Yep.
Okay.
So you would see the YouTube comments were actually the crappiest data I have ever worked with. But you would see there are comments on maybe platforms like Reddit, right? They're much better quality. And then on, let's say, Quora or other discussion platforms, the quality of data is really good at some places. But like I said, it depends from platform to platform, or like I said, let's teach grammar to everyone so that, we don't face this as a problem at all. Data is good, we can work with it, get the insights.
For analysis. And maybe one of the last questions. Oh yeah, how are you doing for time? Because we have like 4 more questions. Is that okay?
Oh, good. Yeah.
Okay. There are many things you have tried during your ML machine learning works. Do you have any tips to keep track of many models, techniques you have tried in an organized manner? Thank you.
Yeah, so there are actually a lot of tools out there now. So one is using the machine learning pipelines. That really helps. One of the tools that we ended up using is WAN-DB. It's really good. You just put a couple of lines in your code and it kind of keeps track of what was the run like, what were the numbers, what were the hyperparameters during that run. And at the end of the day, then you can see, okay, out of these, 100 different variations I tried, this is something that's giving me the best results or something that I'm looking for. So yeah, we tried WAN-DB.
Okay. The next question is, what are some ready-built machine learning pipelines that you would recommend? So I guess kind of the same.
Yeah, so it's for pipelines specifically, there are actually plenty of them out there. Now, even Spacey has a sentiment analysis pipeline. Transformers library, there is a sentiment analysis pipeline out there. But for us, it was like, we wanted to have more control over what goes into that pipeline. We definitely tried them and looked that the numbers were not so great. So for example, some of these pipelines are just doing binary classification. So how do you adjust them to 5-class or 4-class or 3-class classification? That's one of the challenges that we couldn't deal with, and we went for an in-house pipeline that we built.
The next question is, how do you cope with ambiguous emotions or feelings in the comments? For example, one comment may express a variety of emotions such as boredom and disappointment. Yeah, so if we don't use like just traditional, like, I guess, yeah, if we don't just use like positive, negative, but yeah, this sort of like in between.
And actually, this is a great question because that's where our machine learning models are failing. Now, I would say it's ambiguous for us also. We humans are only 80% accurate at this. So here's an experiment that we did with our data annotators. We labeled about 1,000 data points in-house. We had 7 annotators do that. And guess what? There were about 400 comments in them for which people said, yeah, it's very positive, neutral, negative, and somewhat negative. There were like the whole, full coverage. So you can understand if the problem is that ambiguous, how can we expect our models to perform well on that? So what we ended up doing was, okay, if there are like this mixed emotions, you have to annotate the data one way or another. So we thought, okay, you know what? If there is a slight bit of negativity in the comment, we are going to mark it as negative. Though, overall sense might be positive, but you have to make a decision what negative means for our model, though in general negative would mean something else. But we say if there is some negativity in the comment, there is boredom and stuff like that, we are going to call it negative. So those are the business decisions that you have to eventually make. Okay,
and then the last question for this session is, what is the best way to communicate the importance of ethics to stakeholders who may not be familiar with data science ethics already? So, yeah.
Yeah. So one of the recent works that I have seen on how do we convey the ethical implications of our model is using something called a fact sheet. Back at IBM, when I was working, this was the team that said, hey, on our food labels, we have all the facts, the calories, the potassium, the protein levels, right? It helps build a trust that, yeah, I want to consume this. So how about we do a fact sheets for our models? And it's kind of widely used now. So on that fact sheet, you can state, hey, this model has been tested against bias on maybe gender, and it has been, it's supposed to be not biased against this thing, but it has been tested on this XYZ things. It has this carbon footprint. It was trained on this data, and it's compliant to GDPR, HIPAA. So state those facts. I think that's what makes us trust AI more. And that's something that I think even the non data scientist people can understand. It's for generic people. Everybody understand what this model means. And if you still want to consume it, you understand the risks while you consume it or use it.
Do you think so? It's like making it more bite size or summarizing it really briefly that helps as well.
Yeah. Definitely check out like fact sheets. That's what they call AI model fact sheets to understand some more work that has been done around this.
Okay, thanks. So I'm going to stop